9.3 representing linear functions. Today we'll represent a linear function through tables and graphs. A linear function, as stated in your vocabulary there, it forms a straight line. Linear means straight, so everything today will form a straight line. If it's not, we did something incorrect. So what we need to do in order to graph a linear function, first step, we have 3 steps here. We need to choose some values for x. Make a function table, XY table, include a column of ordered pairs for the x and y value. So here's normally your table there that you would set up. Graph each ordered pair, and then you're going to draw a line that passes through each point. Again, linear functions have straight lines. An ordered pair that you get from the table up here is called a solution. It is an answer. It makes the equation or statement true. First example here. During a clearance sale, a music store is selling CDs for $3 and tapes for $1. Graph the function 3y plus y equals 6 to find out how many CDs and tapes Bill can buy for $6. In order to graph this problem, what you need to do is you need to solve for y. So it's kind of like what we had with literal equations. We need to solve for y. In order to solve for y, you need to get y by itself. So to get y alone, we need to get rid of 3x. In order to get rid of a positive 3x, we subtract 3x from both sides. So the 3x's would cancel. We drop the y down. We get negative 3x plus 6. Now, also what you probably need to do, looking at this equation up here, we know that 6 represents the amount of money he has, right? Well, we have 3x and y. We should also know what x and y represent, okay? X is next to 3. If you look back up in your problem here, 3 is talking about the price of CDs. So x is talking CDs. Y is only $1. So y is talking about tapes. So now we know what our x and y values are talking about. Now that we have our equation, the next thing we're going to do is fill out our table. Well, there's that equation that we figured out previously or prior. I think on the prior one we have y equals negative 3x plus 6, saying the same thing. Now we need to go ahead and come up with values for x. Remember what x is talking about. Normally in the past we've used values like negative 1, 0, 1. You're not going to use that in this case because x is talking about CDs, remember, and you're not going to have a negative 1 CD, so we're not going to start with negative 1. Now you can have 0 CDs, so I'm going to start with 0, and I'll go 1 and 2. And then you're going to plug this information into the next column here. So we have y equals negative 3, and for x is 0 plus 6, and then we can go ahead and solve for y. Here we get negative 3 times 0 is 0 plus 6, so we find out y is 6. So the ordered pair is 0, 6. And go ahead and fill in the rest of the table here. Here we would get negative 3 plus 6, and we find out that that would be 3. Down here we have negative 6 plus 6. That would give me 0. So then my ordered pairs here I would have as 1, 3, and 2, 0. Basically what it's saying is, if you think about it, these first values are x values, the next value is a y value. X, in the first problem here, we have 0 CDs to y. Y is talking tapes, 6 tapes. The next one is 1 CD, 3 tapes, and 2 CDs, 0 tapes. Next, we're going to go ahead and graph this. Well, what you'll want to do is label your axis. Here's these solutions that we had. Remember from our prior table, we had 0, 6 that you have on your paper already. We have 1, 3, and we had 2, 0. What you want to go ahead in your graph is label these axes. So here's my x-axis. So this axis here is talking about CDs, and the y-axis here is talking about tapes. So we'll go ahead and plot them here. 0, 6. 0, 6, plot. 1, 3, so we come over 1, up 3, plot, and over 2, and we don't move anywhere, so there's 0. So right there, we can go ahead and graph this line through those points. Now that line is straight. It's a linear line. It's a linear function, as mentioned before. So again, these are our solutions, and we know what each of them means. So basically what it's telling us is with only $6 in that question, you can purchase your X and Y options. In example 2, I want you to go ahead and fill in your table to start off. So go ahead and put in your X values, also known as your domain values. So put in your values, fill in all your table, and then we'll go ahead and check back in once you kind of have everything filled out like I have just done in our first example there. So fill in the rest of the table and check back in. Alright, we should have our table filled in for the following equation. Y equals x minus 3 should look something similar to this, where we have all of our ordered pairs right there listed. So the next thing I would like you to do from that table is go ahead and plot your points to graph. And I have these ordered pairs right here, and you have them on your table as well. So go ahead and plot them on our graph. Remember, it's a linear function or a linear equation, so all your dots or points should line up and construct that line. Here's what our plot should look like. Next thing, go ahead, grab that straight edge and draw the linear line. And what I want to point out, as noted below, it says note that all the ordered pairs for any point on this line is a solution. So all those red dots or other dots that we could potentially put on here, these are all considered solutions. All these dots, they're all true statements for that line for the equation y equals x minus 3. The next part I want you to go ahead and figure out that we have to fill is, says it appears from the graph that -1, -4 is also a solution. Check to see if it's a solution, meaning is it a true statement. So if we look at our graph, -1, -4, over -1, down -4, looks to be the plot right there. We want to know, is it really a solution? Well, in order to test this, start with your original equation, which is y equals x minus 3. And what you're going to do is you're going to plug this ordered pair into that equation. Remember, -1 is an x value, and y is -4. So when you put in -1 for x, you should get out -4 for y. So let's check it out. We have in for y is -4. In for x is -1. We'll drop down -3. Is -4 equal to -1 minus 3 is -4. So it checks out. -4 is equal to -4. So yes, -1, -4 is a solution. The next part it's going to ask is, say, is 1215 or 1512 a solution on the graph? Well, if you look at our graph there, we're not able to tell from our graph, so you'll actually have to plug it in. So again, start with your equation, that original equation, y equals x minus 3, and I'll put y equals x minus 3. This is x, this is y, and the first one, 1215, x, y. So in the first graph, I'll put in the first ordered pair here. In for y is 15 equals, in for x is 12 minus 3. 15 is not equal to 12 minus 3, which would come up with 9. So no, this is not a solution. They are not equal to one another. Second one we want to know is this 15, 12. Is that ordered pair? Would that fall in the line? Is that a solution? Plug the values in. In for y, we'll put in 12 equals. In for x is 15. We're using this ordered pair here. Minus 3. 12 equals 12. So yes, that point would fall on the line. It is a solution. Yes, 15, 12 is a solution. Our last thing here, we need to determine which line graph below best represents the table of values for the ordered pairs x, y. Basically what we have here is we have the ordered pair 0, 1, 1, 3, 2, 5, and 3, 7. So if you were to plot these, we want to know which one is, or which line covers those plots. The first one we have is 0, 1. Well, that is over nowhere and up 1. That would be here. So we know A is ruled out for that plot. 0, 1. Well, looks like it could happen. B might be a potential possibility. Next one, C, 0, 1. I'm just plotting that first ordered pair that we have here. Nope, not going to work. D, 0, 1. Yep, works. So right now my options are between B and D. What you need to go ahead and do is plot the next one. Well, 1, 3. Over 1, up 3. And that's from your origin here. Over 1, up 3 would be here. Not going to work. Let's try D though, just to check out. Over 1, up 3. There's your plot. So D is our only solution there for this last example. This will conclude 9-3 representing linear functions.